I'm basically explaining IGCSE and O-Level P2 algorithms and problem solving. Like the first two things. So first, we discuss algorithms. Algorithms are basically what they basically are. They basically are what basically is the process through which a computer does a task. It is basically like an algorithm can be basically I opening up this concepts app or using my S Pen to write on this or anything like that. Okay, and other than that, we'll talk about algorithms are the task and are the task computers. That's the definition I am personally giving it, but you can find better definition in the book. This is just a primary example. After are the tasks that computers do. Computers are programmed to do or programmed to do or carry out. Now, mainly we will cover how we basically attempt to represent this first. There are four different types of methods to represent algorithms in our syllabus. So the first one is pseudocode, which is the most important. We will go from a list from most to least important. Pseudocode is basically representation of information, representation of info of algorithms, sorry, not info, algorithms representation of algorithms pseudocode that resembles real code, that resembles or attempts to resemble real code. It basically is it's like a language like Python. It's like a language like Python plus the English language. Sorry, I zoned out a bit, but that's fine. Plus an English language. Next, below we will talk about basically flowcharts. Flowcharts basically are another way of representing code or an algorithm. Basically, flowcharts have like this input output like this. What an input output basically what the user inputs into a computer, and the system is basically what calculates it, and then it will give an output. There's also a system here. Flowchart system, input output. Input output flowchart system. Then we have process, then we have a choice, and it goes on and on. It's another way of representing algorithms, another way. Another way of representing the algorithm. Next we have system and system diagram. So subsystem diagram. Basically, subsystems are diagrams that basically overall they give an overall function of our computer, like our a problem it is trying to solve. Like just like how we try to use it to solve other problem, a computer to solve problem. This is another representation. Sorry if I'm repeating this, but basically we will have a solution to a problem such as clock, alarm system. It will be divided into different functions like this until it breaks down into a single function which cannot be further broken down. System subsystem. Okay, since we have done this, now we will talk about also this is also called a top down system. So the top down system or a subsystem basically. Then we have structural diagrams which much isn't discussed in our syllabus, which for that I will not talk about as I do not have knowledge myself. Structural diagrams. Now algorithm basically these are representation of data of in algorithms, representation of algorithms. Next we will talk about the data types contained inside an algorithm. Data types. And let me write it down in English. Sorry if I zone out a bit. I'm just trying, and this is just an example video. It's not like I'm making a whole lecture series, so do be noted. Data types basically there are, first of all we have real and integer. These are both numbers, real and integer. Real integer only has 2 or 1 or -1, no decimal values, but has decimal values. So next we have char, which is basically one representation of like a character, like a single character. To be honest, like there are differences between string char basically can also represent numbers, but it will use a single character. There's nothing more, nothing less. String will have multiple. String hello world is a common example. Hello world. Then we have boolean, which is basically yes or no. Like basically you are given two choices and you have to decide between those two choices. You will either say yes or no, and there is nothing else other than that. That is a boolean data type. So data type itself is basically the type of information put into our algorithm that will be processed, and it will be processed according to what type of data type it is, if you know what I'm saying. Identifiers, now these are variable. These things all are variables, like this. Variables. Like some of these are variables, some are not variables. Some are variables, some are not. So basically, these variables are basically, yeah, like you have a box, you put a string in it, like, and then this string will remain in it until like when the code is being executed, it will like remain in there. After a code is executed, it will be then empty. But and then there are a type of variable called identifiers that are different from variables in the way that they basically are identifiers are basically types of variables that do not change from or within, like this remain they do not like are emptied from their boxes, they rather remain in their boxes. Next we have part of pseudocode, things that are in pseudocode. Pseudocode, like there are logic statements, and not or. These are also Boolean data types, and after that we have also conditional statements. These are like if, like a call, like if like this will basically give us two options, like if we are like age, I will give a full example here. Conditional statements: if age greater than 18, output then over 18 slash adult. There are many ways to say this, but I prefer adding both over 18 adult, else too young. This is an example of conditional statement. Basically, it gives your code versatility to account for different options there may be. Basically, next we have counting and totaling. Now counting is basically the checking of information. I will show a prime example in pseudocode. So basically what this is, so we have num, this is a number, num plus 1. This will keep checking the amount of new values of something, like the amount of usernames. There are already like every day there's like 10 usernames, so it will keep doing this over 10 times until we have a new name. It basically is counting the amount of increasing username, and totaling will be the sum of all values being calculated. So in the end of like an year, you will calculate the amount of people we get inside like that website I just mentioned, sum of all values being calculated.